Good morning. I am Reggie, Associate Professor, Department of ECE, Rogani College of Engineering. Today we are going to discuss about wavelength and velocity of propagation, reflection factor and reflection loss. So in this class we are discussing about first wavelength and velocity of propagation. On completion of course, students will be able to define wavelength and velocity of propagation. For a open wire line, beta equal to 0.04 radian per second, what is the wavelength and velocity of 160 Hz? Can calculate the time taken to travel 90 kilometers. Write the formula for attenuation constant, phase constant and velocity of propagation. Wavelength and velocity of propagation. What is a wavelength? The distance with which wave changes its phase by 2 pi radian is called wavelength. What we already studied in this previous distortion. The distance the wave travel along the line where the phase angle is changing to 2 pi radian is called as wavelength. It is denoted by the letter lambda. Lambda is equal to 2 pi by beta. Propagation of current from sending end towards the receiving end. Consider the phase angle from 0 to 360 degree. Here as we know that lambda is equal to V by F, gravity equal lambda F, V is the velocity, F is the frequency, V is equal to 2 pi by beta, V is equal to omega by beta, lambda is equal to 2 pi by beta, lambda is equal to 2 pi F. Velocity of propagation. The velocity of propagation along the line depend upon the change in the phase along the line. Therefore, velocity is called phase velocity or wave velocity. Gamma equal to ln of V1 by V2 or ln of I1 by I2. Here in this velocity of propagation, gamma equal to alpha plus j beta. In this we will get gamma equal to root zy, where here z equal to r plus j omega l, y is equal to g plus j omega c. Substitute in this equation gamma equal to r plus j omega l, g plus j omega c. If you take the real and imaginary part separately, so alpha plus j beta square root of rg minus omega square lc plus j into omega rc plus omega lg. Squaring on both sides we will get alpha plus j beta the whole square equal to rg minus omega square lc plus j omega rc plus omega l square. So equating the real part and imaginary part separately, alpha square beta is equal to rg plus omega square lc. Velocity of propagation 2 alpha beta equal to omega rc plus omega lg. So 2 alpha beta is equal to omega rc plus lg. From this equation we know that alpha square is equal to rg minus omega square l square plus beta square. So squaring on both sides we will get the value 4 rg minus omega square l square plus beta square into beta square is equal to omega square rc plus lc. So finally we will get the value in terms of beta power 4, and you will find out the square root of beta square. As we know in mathematical expression, ax power 4 plus bx square plus c is equal to x square minus b plus or minus square root of b square minus 4ac2 by 2a, which is the quadratic expression. We are same thing we are applying here, and we are getting the value of beta square. If you applying regulate the negative value, beta is equal to square root of omega square lc minus rg plus square root of rg minus omega square lc the whole square plus omega square rc plus lg the whole square by 2. So substituting the value of alpha square, we will get the value of alpha and alpha square. So both the value can be determined and we will get the value of alpha. If for a perfectly matched line, r is equal to 0, g is equal to 0, and the above condition if you applied, you will get beta is equal to omega square lc plus omega square lc. So beta is equal to omega root lc. The velocity of propagation for ideal line is given by v is equal to omega by beta, v is equal to omega root lc. So v is equal to 1 by root lc. Velocity of propagation can be determined using the value of beta. So most of the cases, if you want to know, you should note the velocity value. Similarly, we can calculate it for reflection coefficient. The phase and group velocity